Today we're going to apply common naming to branched alkanes. Alkanes can be named using the IUPAC system, where we focus on drawing a line through the longest continuous carbon chain, and then looking for groups coming off of that chain and naming those groups. In common naming, we're going to flip the order in which we do these things, and instead we're going to first look for functional groups that are on the molecule and make those the root name, the parent name, if you will, of the molecule. And then the alkyl chain becomes the group that is coming off of that root, and we need to figure out its degree of substitution. We're going to focus on that in a second. What kind of root names could we be looking for? We could be looking for halogens like fluorine, chlorine, bromine, iodine. That's what we're going to focus on today. You could apply these to all sorts of functional groups. You could apply them to alcohol functional groups too. We're going to focus on halogens for today. We are going to focus on the common naming portion of the flow map and figure out if our alkyl group is primary, secondary, or tertiary. Let's start with examples of 4 carbons. The prefix for 4 is butyl, so let's start with an N-butyl group. N for normal or straight chain, so if we have a functional group X, then it would be attached to 4 carbons. For the rest of these examples, I'm just going to draw carbon backbones, but keep in mind that those carbon backbones would all have the appropriate number of hydrogens on them. So there's our N-butyl. How do we make isobutyl? Well, isobutyl needs to remove one of the 4 carbons off of the end of the chain and put it elsewhere on the chain as a branch to make an isomer. If you were to place the carbon right here, you would actually still have 4 carbons in a row. So you would not have an isomer. So we can't place it there. If we were to place it right here, we're going to learn that we would have a secondary group that goes over here. So we actually have only one choice, but to put it in the middle to make isobutyl. And that keeps this first carbon primary. So what's primary all about? Primary is about the fact that this carbon that is attached to the functional group is only attached to one other carbon. So this carbon is only attached to one other carbon here, making it primary. Well, what does it mean to be secondary then? Then you would have sec-butyl. Sec-butyl is going to have this carbon attached to the functional group, attached to 2 other carbons. That gives us 3 out of the total 4 carbons that we need. So in this case, our carbon of interest right here, the one that's attached to a functional group, it's actually attached to 2 other carbons. That's what makes it secondary, these 2 bonds to neighboring carbons. So what does it mean to be tertiary or to have T-butyl? Well, we need this carbon attached to the functional groups to be attached to 1, 2, 3 other carbons. So what do we have then? Well, we have this carbon of interest, the one attached to our functional group, and we have it attached to 1, 2, 3 other carbons. That's what makes it tertiary. Let's try another example. Let's keep going and let's look at 5 carbons. At 5 carbons, N-pentyl we'll have 1, 2, 3, 4, 5 carbons in a row. What will isopental look like? In isopental, we're going to take one carbon off the end of the chain, and we're going to make that branch closest to the end of the chain. We need to make sure that this carbon of interest is only attached to one other carbon. We need to make sure that this carbon of interest is only attached to one other carbon. That's what makes it an iso group. Also, what's important to note for iso is that you're going to have that branch at the very end of your chain. So it comes off of the second to last carbon atom at the end of the carbon chain. So what does sec-pental look like? Sec-pental will have that fifth carbon as a branch in order to ensure that this carbon of interest connected to the functional group is connected to two carbons, making it secondary. And lastly, terpental. We need to have that carbon of interest connected to three other carbons, but that only gives us 4 total carbons. That looks like a butyl group. So we need to extend one chain, the main chain, to make sure that we end up with our total of 5 carbons. In looking at 3 carbons, we'll first just have N-propyl. But what happens when we get to isopropyl? Well, we have our 3 carbons. We go ahead and we erase one, and we try to make an isomer. Well, when we go one end from the end of the chain, we put our carbon right here on the middle carbon. And when we put it on the middle carbon, if we examine this really closely, what we notice is that this carbon of interest is actually attached to 2 carbons. Notice here is that isopropyl actually is secondary. So isopropyl is a special exception to the rules in that isopropyl really belongs over here because isopropyl happens to have a secondary carbon. What does that mean you should look out for? Well, look out for accidentally naming a molecule sec-propyl because there's no such thing as sec-propyl. That does not exist. So now you can apply the common naming roots to different problems.